I can explain either one or both, or how I got all these numbers.
Explain both, please.
Sure. So remember we said that if you have an angle, pi over 6, pi over 4, and pi over 3, sine and cosine, that's the only thing you have to remember. And this is, in my opinion, simple to remember. 1/2, 1/2, the square root of 3 over 2, the square root of 3 over 2, the square root of 2 over 2, the square root of 2 over 2. So if I'm asked like in cotangent of pi over 3, this is 1 over tangent pi over 3. And what is tangent? Sine over cosine. So sine for pi over 3 over cosine, when I divide these two, I get the square root of 3. This over this is the square root of 3. So this will be 1 over the square root of 3. And that's it. Now, and you can rationalize it. For cotangent pi over 6, I know it's 1 over tangent pi over 6. The tangent pi over 6 is sine over cosine. So 1/2 over this, when you flip those two, because you know how to divide two fractions, you will get 1 over the square, 1 over 1 over the square root of 3. So this is the square root of 3. Now, some prefer to just memorize those numbers. I don't. I know these, and I can always divide this by this, or this by this, or this by this, or this by this. That's the easiest thing. It's easier for me than remembering the square root of 3 over 3, or 1 over the square root of 3, or the square root of 3. This is so much easier for me. But others say, no, I would like to memorize the rest of the table. Go ahead and memorize the rest of the table, if that's what you want. But that's the basic. If you ask me anything, I just base it on this. If you ask me, for example, I don't know, secant 45, I will have 1 over cosine. If you ask me, or 5 over 4, in other words. If you ask me find tangent of pi over 3, I'll say no problem. This over this is the square root of 3. If you say find cosecant of pi over 6, well, cosecant is 1 over sine, so it's 2. That's what I recommend. But it's just a recommendation, just a suggestion. Good, very good problem. So let's move on to other questions. Anything else you would like to review? Any problem that you would like to work on now? Anything you need help with? Don't be shy. Any problem? Let's do it.
Real quick, just to rehash something, you did say that I'm just asking, this is just a question that you can answer. During solving that problem, you said that the cosecant squared, the good Lord, not the derivative.
The antiderivative.
The antiderivative was cotangent.
Right. So let's take a look. So if I have cotangent prime, I get negative cosecant squared. If I have tangent prime, I get secant squared, right?
Right.
So if I integrate this, I get tangent. But now, if I integrate this, I get negative cotangent.
I see.
Better?
Oh, I get it. Absolutely.
Yeah, so also there is a problem with this function and with this function because we don't have it in the graphing calculator. So they have to change this into 1 over cosine squared, and you have to change this one into 1 over sine squared. That's the difficult part. And you need to have enough parentheses for this to work properly. Good questions. Very good. Next question. Anything?
I was just looking over test 4, the old test 4.
Yes.
Can you do number 9?
Yes. Number 9 from the old test. Let me share my screen and find the test. Where are you guys? This one. Number 9. Yes, so we have the integral from 0 to 9 from f of x dx. We had a homework problem. I think I copied it from there. Last time, I think it was. Or something similar. Let's take a look. Okay, by the properties of the definite integral, we know that this integral from the sum of two functions will be 4, the integral from 0 to 9 from f of x dx, plus 6, the integral from 0 to 9 from g of x dx. This happens with limits. This happens with the summation notation. This is the same property over and over. And now I have this piece, which is 37, and I have this piece, which is 14. And I only need to calculate 4 times 37 plus 6 times 14. And I'm lazy. 4 times 37 plus 6 times 14, 232. Anything else we want to look at or need help with?
Can you do the last one? I know we had a question like that on the written homework that was due today.
The last one, you mean, what do you mean by the last?
In the old test, we had a question just like this in the written homework.
You talk about this one?
Mm-hmm.
Yes, so let's take a look. And we're looking at, that's my page 10. Good. So a of t equals t plus 4. V of 0 equals 7. The interval is 0 to 10. And they want us to find the velocity at time t, and then the distance traveled between the given time interval. Okay, perfect. So in order to determine the velocity, we have to integrate t plus 4 dt. That's the function, which is t squared over 2 plus 4t plus a constant c. We're given that v of 0 is 7, 0, 0, so this will be 7. So then v of t is t squared over 2 plus 4t and plus 7. Now for the total distance, this is the 0 to 10 of v of t dt. Is this okay so far? Sorry, I just muted everybody, so unmute yourself, Janil. I'm sorry.
Oh, sorry. I got it up until you wrote the total distance part.
Okay, but so far, is it okay?
Yeah.
Yeah, and this is the total or the net change theorem. Net change. This is the theorem.
Professor,
Yes.
If we don't write I know that it has to be, the math has to work out to be the absolute value, but if we don't write our formula as it is the absolute value, will we lose points for that?
Yeah, because you're not adding the distances. That's a very good question, Sean. So remember, the particle can do this. And if you're not using the absolute value, you will subtract from positive distance, you will subtract the negative distance, and you will add the positive distance. But there is no negative distance.
Okay.
So the absolute value takes care of the direction of the particle. So in other words, look, so I go from home to school and back. My odometer should show 0 because I have 15 miles this way and negative 15 miles this way. But will my odometer say 0 or will my odometer say 30? I would love to.
It'll say,
I have
30.
365 on one car. I have 365 miles.
yeah, no negatives.
It's a 20-year-old car, and I bought it with 10. So the odometer should say 0 because I went back and forth, right? But it will say 30. So if you don't put the absolute value, that's why the absolute value is there,
I
to
got
make
you.
sure that all distances are added.
I'm with you. Just in my head, I saw all the positives. I was like, oh, it's good.
Now, it's a very
Okay.
good point. You are raising a different point. If this function is always positive on 0 to 10, then I don't need the absolute value.
I see. Okay.
I completely agree. Because if this is always positive on 0 to 10, who cares about the absolute value? So we can do that by simply starting by graphing the function. That's a very good point. And then I can drop the absolute value. If indeed this function is always positive on 0 to 10, then who cares? So let me share my screen. Very good point. So I will do this. 0.5 t squared plus 4 x plus 7. Okay, and graph it. It's quadratic. It has a minimum. Negative b over 2a. So the negative. So yeah, we'll see in a moment. It could be. So let me think for a second about the x-intercepts. B squared minus 4ac. Yep. Okay, got it. So I want to graph using standard. Let's see what happens. Haha, very nice. On 0 to 10 is always positive. Okay, so between 0 and 10, the function is always positive. So in this particular case, indeed, that's true. I don't need the absolute value. So then the total distance in this case is 0 to 10 from t squared over 2 plus 4t plus 7 dt. But you understand the difference, right? So this is 1/2 t to the third over 3 plus 4 t squared over 2 plus 7t from 0 to 10. I love 0 as the lower limit because I don't have to do anything, just plug in 10. So 1/6, 1,000 plus 200 plus 70, whatever that is. It'll simplify. So 500 over 3 plus 270, and I multiply this by 3. So 500 plus, what is this? 80, what is it? Yes, 81. Yeah, correct. So this is 1310 over 3. So very good point. It is and true, but otherwise I have to break it up as we did in class last time. We have to break it up into two integrals. That's why when we looked at the particle a long time ago in chapter 3, So if you remember, we had the distance. This one was the absolute value of s of 2 minus s of 1. This one was the absolute value of s of 3 minus s of 2. And this one, although this is positive and the third one is positive, we added them in absolute value. So s of 4 minus s of 3. That's what that net change theorem says. Very good point, very good questions.
I have a question.
Ready?
Do you want that answer as a fraction, or did you want the decimal?
No decimals, fraction is better.
Okay.
And of course, I don't know, I don't remember the measurement unit, I think it was meters. So please do not forget measurement units. If the situation is abstract, then you don't have to put any measurement unit. But if it's if you're asked to find velocity or acceleration or whatever, please don't forget measurement units. What else you need help with?
Could we go over number 10 on the practice test?
Yes. Okay. G or F?
Can we do F?
F, very good, awesome. So remember in f of x, so this is 2x to x squared e to t squared dt. You can only be asked to find the derivative. This is a function. It is given in a form of an integral. Don't even try to do anything else. We're only asked to find the derivative. Okay, so it's not ready for part 1. So I have to break it up. 2x to whatever you want from e to t squared dt plus from whatever the same number to x squared e to t squared dt. This is okay, but this has to be flipped. So it changes its sign. When we change the limits of integration in any definite integral, we put a minus in front. Now it's ready, full stop. It is ready now for differentiation. So f prime of x is e2. I replace t by 2x and I square it. So I get 4x squared times the inner function, of course, minus in front, times the inner function prime, which is 2. Plus, I differentiate this. e2, I didn't mean to write that. I have to plug this in. So x squared squared will be x to the 4th times the inner function prime, which is 2x. And this is it. You can rearrange it if you'd like negative 2e to 4x squared plus 2x e to x to the 4th. You're only asked to differentiate the integral. You're not asked to do anything else. There are other applications of this, but they all involve differentiation of this function, most of them. I can't think of anything that does not.